In this video, I'm going to demonstrate how you would go about solving logarithmic equations. We're going to work two examples out here, but before we do that, I would like to run through some steps of things that might be helpful in remembering when you're trying to solve these logarithmic equations. Alright, the process that I'm going to use is the first thing I'm going to do is I'm going to rewrite my logarithmic equation into exponential form. Alright, then I am going to have an equation at that point that I'm probably going to be able to pretty simply solve for x. Alright, once I have solved for x, then I'm going to make sure and check for extraneous roots. When you're dealing with logarithms, let's say if I've got the log of m base a, both the a and the m have to be positive, so I have to make sure and check for that. Alright, and then I also have to check to make sure that a is not equal to 1. Alright, all things that are dealing with your logarithmic function and things of that nature. Alright, and then I also have to, for the extraneous part, I have to make sure that when I get that answer for x, I can plug it back into my equation and it makes it a true statement. Okay, so just some pointers and things that we need to do when we are solving these logarithmic equations. Okay, so for my first example right here, I am going to solve the log of 2x minus 7 base 3 is equal to 3. And I am going to solve this for x. Alright, step 1 said to rewrite into exponential form. So that's going to be a 3 raised to the 3 equals 2x minus 7. So that's going to be my exponential form. 3 raised to the 3 equals 2x minus 7. Okay, now you can see that I have an equation that I can pretty easily solve here for x. It's going to be a two-step equation. After I evaluate this, 3 raised to the third power is going to be 27 equals the 2x minus 7. I'm going to add 7 to both sides. That's going to give me a 34 equals a 2x. Divide both sides by 2. X is going to be equal to 17. Okay, now first thing I need to do probably is check for those extraneous roots, so I'm going to take 17 and I'm going to put it back into that equation and see if I have a true statement. So let's do that in red here. We are checking the log of 2 times 17 minus 7 base 3, and I'm asking myself, does that equal 3? Okay, you can evaluate this out really quickly. You could, here, 2 times 17 is going to be 34, minus 7 is going to be 27. 3 raised to the third power does equal 27, so this does check. You could check it by hand like I just did. You could also check it on a calculator. Alright, any way you want to do that is going to work. Alright, since this is true, then yes, my answer of 17 does work. Alright, and a lot of times at this point you're going to probably need to write your answer in the form of a solution set. So if you were to write this in the form of a solution set, you'd use your set brackets, 17, and then close your set brackets. And that just depends on, you know, what your teacher is wanting, how your teacher wants the answer, x equals 17 or written as a solution set. Alright, in this example right here, we're going to be solving the log of 64 base x equals 2. Alright, my first step is to rewrite into exponential form. So then I'm going to have an x raised to the second power equals 64. Okay, again, pretty simple equation to solve. I'm going to take square root of both sides, and when I do that I'm going to make sure and remember to do plus or minus. So x equals plus or minus the square root of 64, and square root of 64 is going to give me an 8, so I will have x equals plus or minus an 8. Okay, now I need to make sure and do my checking here. So as I check, alright, first off, the x is the base up here, okay, and I've got a plus or minus 8. Well, over here we said that both our base and what we were taking the log of needs to be positive, so I'm solving for my x right there, which is a base, and I get a negative 8, so right away I can discard the negative 8. So let's just write base must be positive. Alright, so we can discard x equals negative 8. Okay, now I'm going to test my 8 in that equation and see if it works. So then log base 8 of 64, and does that equal to, well, 8 raised to the second power equals 64? Yes, it does. That is true. So then my positive x equals 8 will work as my solution. So if I have to write it as a solution set, then I would have my set brackets, just the positive 8, and then close those set brackets. Okay, so either x equals positive 8 or as a solution set with 8 in it. Alright, so 2 quick examples of how you go about solving logarithmic equations. Okay, just to review real quick, you're going to go into exponential form. You should then have an equation that you can solve pretty easily for x, and then just don't forget you've got to check those answers to make sure they make the original equation true, otherwise you have an extraneous root, and you also have to watch and make sure that both the base and whatever you're taking the log of are both positive and that your a is not equal to 1. So lots of things to consider and remember. Definitely thanks for watching. If you like the video, give me a thumbs up and be sure and share the video with your friends. Thanks.